All right, this is 15 on the reporting category 2 practice. The unusual strength of a glue makes it able to hold a heavy object or load as shown in the diagram below. All right, if the load exerts a strong downward force, then the glue does what? Well, this is a classic Newton's third law. Basically, load pulls down. That means the glue is going to have to pull up. And the forces are always equal and opposite. So A doesn't make any sense. B doesn't make sense because it says it exerts a stronger downward force. That's not true. Causes the load to accelerate upward. No. And D exerts an upward force that's equal to the downward force. So there's your answer is D. All right, number 22, a meteor moving 468 kilometers per minute, traveling in a south to north direction, passed near Earth in 2013. Because the meteor was only 45 meters wide and was 27,700 kilometers above the Earth's surface, it was not visible without the aid of a telescope. Which statement describes the meteor's motion? Well, first of all, in this question, you need to understand that there are some numbers in here that you don't need in order to figure out your answer, and they actually put these in to throw you off. Which describes the meteor's motion? Well, F talks about velocity, G talks about acceleration, H talks about speed, J talks about acceleration. Okay. Its velocity was 7.8 kilometers per second northward. Well, it does give you a velocity up here, 468 kilometers per minute, and this one is in kilometers per second. That's not necessarily wrong. It's just in different units, so we have to keep looking. And it does say in a south to north, so northward would be okay. F, we're not going to eliminate. G says its acceleration was 468 kilometers per second squared. The 468 was kilometers per minute, so G doesn't make any sense. Scratch it out. Because the units don't make sense. H, its speed was 468 kilometers per second northward. No, it just said in the problem that it was 468 kilometers per minute northward. So H is out. Its acceleration was 7.8 kilometers per second squared. It didn't tell you anything that would indicate that this object, this meteor, is speeding up or slowing down. It just simply gave you a speed and a direction, so it gave you a velocity, and it doesn't give you any information to indicate that the velocity has changed. So J is probably out. If you take 468 and divide it by 60, because there are 60 seconds in a minute, when you do that, 468 divided by 60 actually gives you 7.8 kilometers per second. So its velocity is 7.8 kilometers per second northward, because that's equivalent to saying 468 kilometers per minute northward. Okay? All right, 40 says, a leaf fell from a tree branch. The path it followed is shown in the diagram below. Which of these best describes why the leaf fell in a crooked path instead of straight down? All right, objects with irregular shapes never fall in straight lines. That's not necessarily the case. Air currents and gravity applied changing and unbalanced forces to the leaf. I will say that if you took that leaf and you dropped it on the moon where there is no air, it would fall straight down. Okay? So probably air currents have something to do with it. The upward force of the air on the leaf was greater than the downward force of gravity. Well, if the upward force was greater than the downward force, then the leaf would be going up and not down. So that doesn't make any sense either. Once the leaf was in motion, it continued moving in the same direction because the forces were balanced. Well, it kind of made its way wanderingly down, but that's because air currents and gravity and stuff were, well, air currents primarily, were kind of playing with the leaf and blowing it here and there as it wandered its way down. A leaf is very light, so air resistance will act on it very quickly, and it won't accelerate. It'll just kind of sit there on the breeze and fall gradually because the air currents have so much influence on it. Okay? All right, so your answer on 40 is G. Really, that's one of those questions where pick the thing that makes the most sense. You know, not one of them is going to, like, just blare out at you, but that is sensible. So use common sense. All right, last one, 34. A student kicks a soccer ball 3 times. Another student records the distance, the amount of time the ball travels, and the average speed. The table is shown in the table below. How many seconds did it take for the ball to travel 30 meters during kick number 3? So really, you don't need to do much of anything with kick number 1 or kick number 2. Let's calculate for kick number 3. Okay, so your formula on your formula chart is actually speed is equal to distance divided by time, and they're asking you about time. So really, the formula, the way it's given, is not super helpful. We would need to know what time was equal to. And time, if you know how to rearrange, time is equal to distance divided by speed. So let's see if we can figure out how this is going to work. 55 divided by 5 is 11. 50 divided by 5 is 10. 30 divided by what is 15? So you can kind of reason it out that way if you couldn't figure out how to rearrange the formula. So 30 divided by what gives you 15, because it's the same pattern for all 3 of them. And 30 divided by 2 is going to give you 15, so the answer is J.